In this example, we need to prove that these two triangles are congruent, and we're given a few pieces of information. LM congruent to OP is written here. That's given. We'll want to mark that on the diagram. So here's LM, and here's OP. N is the midpoint of MO is here, and it's given. And the other statement that we're missing is LN is congruent to PN, and that's given to us. So here's LN, and here's PN. We're actually not allowed to prove that these two triangles are congruent yet. We only have two pieces of information between them that are congruent. We need a third piece. If we look at this statement, it's the one that we really haven't used yet or haven't been able to mark anything on the diagram with. So let's look at it. N is the midpoint of MO. N is the midpoint of MO. Well, that means that MN must be congruent to NO. So let's write that down. MN is congruent to NO. Why is this the case? What's the reason? Well, that's just the definition of a midpoint. It splits a line segment into two congruent pieces. We can now conclude that triangle NML is congruent to NOP. If we look, we have side, side, side. And that's the postulate we'll use here as our reason in the end.